Assassins, to another episode of the Dark Assassins podcast, a show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Probably one of the hardest parts about any project, regardless of discipline, is the fact and the matter of getting started with it. And that's even more evident, especially if you're wanting to, say, learn a new skill or get into a new hobby or something like that. And today I wanted to discuss some of the ways that I've found best help me to learn new things, specifically focusing in the technology realm, because that's, after all, what this podcast is kind of about. But I also wanted to talk about a new security feature that seems to be making the rounds with iPhones, where they quietly reboot themselves, as well as some quite horrendous password etiquette. So that is coming up in this week's episode. But before that, let's start off with our trivia question. So the first x86 processor was the Intel 8086, which was a 16-bit processor that was an extension of Intel's 8-bit 8080 microprocessor. But what year was the Intel 8086 released? So what year was the Intel 8086 released? And that is your trivia question for the week. Now, I mentioned at the top there was a quietly released new security feature for iPhones. So apparently, as of iOS 18, Apple silently rolled out a new feature of sorts to essentially reboot the iPhone after periods of inactivity. Now, initial reports suggest this was originally around 7 days or so in iOS 18, but as of iOS 18.1, it seems like that time is now down to 3 days of inactivity. So now, I guess there's still some speculation that this potentially could be a bug of sorts, but at this point it kind of seems more like this is intentional and an intentional feature rather than a bug. But regardless, depending on who you are, even if this is a bug, it could actually be a feature, kind of going back to that old adage of it's not a bug, it's a feature type of a thing. But the real question we have to ask ourselves is, why is this even a big deal in the first place? Like, why is this even worth mentioning? Like, okay, your phone rebooted after a couple days. What's the big deal? Well, the big deal is that all iOS devices are encrypted, which is fantastic, but as we've stated before, encryption is only good as you let it, right? So if you have a device that's encrypted, when your device is powered off, everything's encrypted and it's great, but if your device is unlocked, your drive's decrypted or unencrypted, I guess, and you can easily get all the data off of it. So encryption is only as good as you let it. And for the iPhone's case, it has what's known as, so it has essentially two states that it can be in for simplicity here. So it has the before first unlock state and the after first unlock state. And the reason this is significant is because each of these basically denote the level of security and encryption and lockdownness, I guess if you will, of the device. So the former, or the before first unlock state, is active after the phone resets or has been powered off. So in this state, certain features are completely unavailable. So until you enter the correct password for the device. So things like notification center, camera, Wi-Fi, biometrics, just to name a few, are all disabled. This is why if you ever restart your phone or after you install a new software update, you're not able to unlock your phone with either Face ID or Touch ID. You have to manually enter your passcode because the iPhone is in this before first unlock state. And the other big thing about this is the file system is also fully encrypted at this point. So if you ever are potentially in a bind where someone might get hold of your phone and try to, steal data off of it, giving your phone a nice good old reboot will make it significantly harder for any would-be attacker or whoever the case may be to gain access to that data because everything is fully locked down at that point. But then, of course, we have the after first unlock state, which when this is active, this is essentially any time after the phone has been signed into at least once with the user's passcode. And at this point, all features are now available. And the key thing to note in this state is not all the components of the file system are encrypted, so it makes it a lot easier to extract data through a tool like Celebrate, which I believe is kind of what law enforcement uses to try to crack iPhones. Now, granted, this is, of course, relative to the before first unlock state, because I'm not saying this is by any means trivial, and pretty much the only way that you're going to be able to do it is through that proprietary hardware and software, that being the Celebrate system. Now, in theory, there's a theory floating around that iOS 18 devices are also able to communicate with non-iOS 18 devices in order to trigger this reboot process as well. Now, there's a couple different ways that this potentially could happen, but assuming we take this theory as legitimate and this is actually happening, personally, I think the most likely manner in which this is happening is done to a similar way that Apple's Find My network works. Now, as I guess a quick recap, whether this communication is done similar to the Find My network or piggybacking off of it, to bring you up to speed, essentially what goes on with Find My is devices use their Bluetooth connection to essentially transmit their signal to neighboring Find My devices, in this case like iPhones, in order to transmit their location even if they don't have any sort of cellular connection. So this is how things like AirTags are able to report their location even though they obviously don't have any kind of Wi-Fi or cellular connectivity. Through the Bluetooth protocol and Bluetooth technology, they're able to essentially transmit their location to other iPhones, and those iPhones will then report to the larger Find My network where those AirTags are located. So in a similar vein, iOS 18 devices may be able to do something through this kind of protocol in order to trigger other iOS devices to reboot. I'm not entirely sure. But yeah, so if you needed another reason to update to iOS 18, this could be a good reason for you to increase your privacy and security in the unfortunate event that you lose access to your device or it gets stolen or whatever the case may be. Having it essentially auto-lock itself down is kind of nice. It honestly would be kind of cool if you could, manually set that, like rather than it doing it by itself after a certain length of time, you could like manually go into the settings and like set it to auto lockdown. Instead of 3 days of inactivity, maybe you trigger it after, 24 hours or something. Now, of course, you don't want to necessarily make it too frequent because then that would just be a hassle, your phone rebooting all the time. Not to mention that would kind of take a hit to your battery life, especially depending on how many times you reboot. But regardless, I think this was rather interesting to hear about. So I just wanted to let you guys know about that. But speaking about security, let's get into this week's cybersecurity tip. Now, this week's cybersecurity tip is a cybersecurity tip I quite honestly never wanted to make. I think I made it pretty clear when I first started incorporating the cybersecurity tips into the podcast that I didn't want to do the cop-out, basic, boring ones, like, make sure you have strong passwords and don't reuse passwords and things like that. And this is probably honestly kind of a cop-out too if you listen to, previous cybersecurity tips. But apparently some out there aren't doing a very good job with their password management and password quality. As I would assume, though, since you are a listener of the Dark Assassins podcast, I would assume you don't fall into this category of not having strong passwords or reusing passwords or things of that nature. But there was a Gizmodo article published this week with some rather awful passwords that are still being used, which I will have a link to their article down in the show notes. But essentially, the folks over at NordPass, which is a password manager, did some analysis over passwords that were stolen either by malware or exposed in data leaks. And essentially, the TLDR here is there's a reason why passwords like 12345, QWERTY1, password, secret, things like that are stereotypes thrown around when referring to bad passwords because they're the top passwords in basically every country that they were able to get data on, which I believe was like 44. So the thing is, these are universally known as bad passwords, yet they're still the most commonly used passwords, at least according to these data leaks or data or passwords stolen by malware. And I don't know. I'm just kind of like facepalming right now because it's 2024 at this point. It's not like password managers are anything new. And if you're really, really that paranoid that some password manager is going to has a backup of your keys and can decrypt, your vault and, steal all your passwords. If you're really that paranoid, there are plenty of self-hosting options so you can host your password manager at your house on your own hardware. And if you really want to, you can completely remove it from any kind of internet connection. So there's no way that that password manager can, phone home, if you will, to report back, to exfiltrate your password database. I mean, there's definitely ways at this point that you can be using a password manager. And if you really, really don't want to use any kind of off-the-shelf thing, you can create your own password manager. You can write the code to do it yourself so you know for a fact that it's not doing anything wonky. So with that out of the way, I think if there's anything to take away from this segment, the first is to use a password manager. Now, preferably this would be one that can generate complex and unique passwords for you, but that's not necessarily a requirement. The main goal of the password manager is to allow you to create very unique passwords and not reuse passwords, yet also be able to keep track of those passwords so you can actually still log into your various accounts. The second thing is to make sure you're using complex and unique passwords for every site, not reusing them, although alternatively you could use our tip from last week and use passphrases instead of passwords. But remember, if you're using a complex password, it should have lowercase and uppercase letters, as well as numbers and special characters like exclamation marks, dollar signs, ampersands, things of that nature. And of course, number 3 is to make sure any account that allows you to enable multi-factor authentication because even if your password were to somehow get detected or leaked through a data breach of some sort, you have that additional layer of protection against a threat actor gaining unauthorized access to your account. And then similarly, depending on what the account is, you could also use things like pass keys or like SSH keys or some other kind of non-password way of authenticating yourself. So yeah, there's honestly at this point in 2024, there's really no excuse for having bad passwords like 123456, password, secret, QWERTY, etc. So hopefully we can let that sink in and use better passwords. And that is your cybersecurity tip for the week. And moving right along, let's get into what nerdy stuff have I been up to this week. Now, this week I did get my hands on a rather interesting item, I guess you could say. If you've been listening for the past couple weeks, you probably know what I'm referring to. But I got some good stuff cooking for next week's Nerdy Things segment, so you'll definitely want to stick around for that. But for this week, I did make some updates to my video game, more specifically to kind of not necessarily even the build process, but in case you're unaware, the Git, which is the version control software that I'm using, has what's known as hooks, which essentially can allow you to do things, before you commit files, after you pull files from a remote. There's a bunch of different things you can do. But I set up a pre-commit hook on my main dev machine and documented it so I can actually remember how to do it, to essentially auto-run Clang format before I commit my code. Now, why this is significant is because, first off, if I mentioned, I don't remember how many episodes back it was at this point, that I created a Clang format for my video game project so I can ensure that the formatting and the style of my code is essentially the same and, fits according to the style guide, if you will, laid out in the Clang format file. And as part of this, it was a rather manual process in order to format everything. Now, there was a couple of ways that I could do this. One, I wrote a script to essentially format all the source files in the project, so I could run that script. Or alternatively, I could run a git clang format command once I committed or once I staged changes. So before I committed them, while they were in the staging area, essentially run git clang format, and then that would auto run the clang format on them to format the code, and then I could go ahead and commit those, re-add potentially and commit those changes. But of course, that was quite the manual process to run every single time, which is pretty gross, I know. So essentially what the pre-commit hook allows me to do is it essentially checks all of the source files. So when I run a commit, so if I add, say, 2 of the source files to the staging area, and then I do a git commit, give it the message, and hit enter, basically what the pre-commit will do was it will check those files, see if they're source files, aka a .h, .cpp, or .c file, and then assuming it's one of those, it will then run Clang format on them and then re-add them to the staging area. So because one thing that's a little annoying about it is if you don't re-add it to the staging area, it will commit the changes without the Clang format being run, and then you'll have the same files in the staging area again with the Clang format run, and it's just kind of annoying. So just at the very end of essentially the pre-hook script there, if you will, it then re-adds the file regardless if it was changed or not, just to make sure that if it was changed, it gets put back in the staging area before the commit is run. So then when the commit is run, all of the formatting has been completed, so there is now no more manual process. So that was definitely a huge win. Now, one thing you should probably note, though, is I made sure to mention that it checks if it's a source file, because originally I did not check that, and when I was modifying my README file, or not the README file, the conventions file that I essentially documented how to set up the pre-commit hook, it completely butchered the formatting of that file, because Clang Format was like, oh, I am going to format this file. And I was like, I didn't want you to format that file. So, had to do a quick little rollback. One of the beautiful things about Git and version control, you can easily roll things back like that. So rolled that back and then made sure to check to make sure it actually was a source file before running the Clang format on it. Because if the file doesn't need Clang format to be run on it, there's no sense in trying it. And then subsequently re-adding it. So that was definitely a huge win. And then as far as actual code updates, I didn't make a ton this week, but I did refactor the navigation arrow slightly to signify that you can scroll down. So previously, when you were kind of scrolling down through the bag options, the way that the arrows determine whether they should be shown or not, specifically the kind of the indicator to show you can scroll up and scroll down, the one specifically for scrolling down was rather ugly, if I'm being honest. So originally I have a Boolean flag essentially set to tell that sprite if it should be visible or not. And the Boolean was set to true if the last index in essentially the array of items being displayed was closed bag, which worked. But if you know how string comparisons work, it's not exactly the most optimized solution in the world. Now, did it have any performance? Was there any performance issue? No. But if you actually, go through and kind of see under the hood how the string comparison works, you're basically going character by character, checking to see if they're the same, and then returning a number value essentially, whether to specify whether or not the strings are the same or one's greater than the other or whatever the case may be. So it's definitely not nearly as efficient. So I did some refactoring basically to signify whether that value is true or not. So essentially, instead of doing a string comparison, in the if statement where I check to see if closed bag should be added as the last element, I just set the Boolean value to true. Or rather to false, because it shouldn't be shown. Now, why I didn't do that in the first place, your guess is as good as mine. I obviously probably wasn't thinking very well. But jokes aside, I did get that working and kind of optimized. So it's a minor optimization, but it's definitely an overall better solution in my opinion. So with that, let's kind of get back to the last thing I wanted to talk about for this episode, which is where do you start? Now, as I kind of touched on at the very beginning of the episode, whenever you're getting into a new hobby, a new career path, or just overall learning a new skill, the question of where do I start always comes up. And it's very easy to get paralyzed and overwhelmed, with an overload of choices and recommendations about where to go about starting. And this can basically apply to anything. It's not strictly limited to things like software development and home labbing, but it also applies to other things as well, like cooking and baking, working on cars, workout routines, playing musical instruments, pretty much whatever. If you're ever looking to get into something new, where do you start is kind of always a question that looms and can be kind of overwhelming once you start to do a little bit of research about potential starting points. Now, since this, of course, is a more of a technology-focused podcast, I will be focusing on those. But my recommendation about where to start for pretty much any kind of topic, but of course, since we're focusing mainly on technology, my recommendation will always be do what excites or intrigues you. Now, if you've listened to the podcast for long enough, you'll know that I love to learn new things but despise formal education. And I think the reason for this is quite simple because there's a big, at least to me anyway, there is a big difference between wanting to learn something or learning something because you want to versus being forced to learn it. And I think your mindset is very different, right? If you've ever, got the motivation, to say clean your room, for instance, you're really gung-ho about doing it, but the second someone tells you to go clean your room, now you don't want to anymore because there's a difference between wanting to do it because you want to do it versus kind of being obligated to or being told to do something. Now, while it wasn't as common, there were a few instances when I was going through my formal education process where, dare I say, I actually enjoyed school. But of course, this was very few and far between. But the cases where this kind of came up were times where the teacher or professor got me passionate about wanting to learn more than rather, force feeding the material I had no interest in. Now, I think I've mentioned it a couple of times on the podcast. Quality teachers and professors, I think, are definitely undervalued and definitely should be paid every dollar they're worth because, quite honestly, I think a lot of teachers are definitely underpaid, but that's kind of especially good teachers anyway. But that's a complete different topic, and we're not going to go down that rabbit hole. But teachers and professors that can inspire their students to want to learn the material rather than essentially telling them you're going to learn this and learn it, I think definitely is kind of the way to go because at least, everyone's different obviously, but at least for me, that was what kind of made me want to learn rather than begrudgingly doing the work. But like with any hobby, of course, you have to know the basics, right? Like if you're working with cars, you should probably know how to change the oil and the oil filter before you go pulling out the engine and transmission and trying to rebuild them. And it's the same thing with software development too. You probably need to know the basics like what variables, loops, and conditionals are before you go off and build your dream application, right? So now you're probably thinking, cool, so you just got all philosophical on us without actually giving any recommendations. And I'm glad you said something, attentive listener of the Peanut Gallery, because that's exactly what we are going to do. So starting off with software development, because that is where I started off, I didn't learn to get good at coding because a class taught me how. Now, sure, that's partially true because I took a class that taught me, what variables are, what for loops were, what switch and if statements are, how while loops work, what functions are, what classes are, things like this. But the reason I say that the class didn't teach me was the reason why I am where I am today and the reason why I enjoy coding so much partly was because I was constantly playing with and experimenting with code to see what I could do with it. I wasn't sure I did the assignments and everything, but in addition to that, I was constantly trying to figure out what else I could do with this program. So the first real language that I started to learn to program in was Java back in high school. And we started to learn the basics through a library and or framework called jcarol. And jcarol was essentially a basic library that would create an environment for you, and you would be able to essentially control the movements of a little robot on the screen. So you could essentially move the robot forward, you could turn the robot, you could pick up beepers, and you could do a very limited number of things with it, but it kind of helped you understand write the basics of kind of writing code. And Probably the most memorable thing I did with this J. Carroll robot thing was I made them dance. And not just one, but enough to fill the whole screen. Now, why did I do this? Because quite honestly, I just wanted to. I wasn't told to do it. I had no assignment that required it. I just wanted to see what I could do and what I could make this little robot do. So that's one example. But also kind of back in high school, I got really into like random physics calculations for kind of no reason at all. And one of them was time travel, specifically the calculation for time dilation, or essentially the idea that the closer you get to the speed of light, the slower time passes for you relative to everyone else. Thus, you essentially can travel forward in time. So I essentially wrote a program to use the time dilation formula to calculate time travel. Now, this program is actually one of the ones that's actually up on my GitHub if you're really interested to check it out. But essentially, it was a very simple command line program that would prompt the user to either give the destination time and time traveled, the destination time and the speed they're traveling at, or the time traveled and the speed, and based on what selection was given, it would then calculate the other one, right? So if you gave the destination time and the time traveled, it would give you the speed that you would have gone. If you gave the destination time and the speed, it would give you the time traveled. And if you gave the time traveled and the speed, it would give you the destination time. So it was very, pretty basic, but, there was a lot of things in there to help me learn programming, right? Classes, object-oriented programming, some basic math, if you will, how to do various math operations, conditionals, dealing with user input, things like that, and all because I wanted to write this program. Another program I wrote was to solve Einstein's E=mc² equation, but probably my favorite program I think that I wrote in high school was a program to essentially simulate a World War II pilot in a plane that was like a bomber, and essentially it would tell you when to drop your bomb. If you basically tell it, what your speed and altitude are. So basically, it was a very simple projectile motion calculator. And of course, it ignored air resistance because, like with any high school physics class, you always ignore air resistance because air resistance obviously doesn't exist. That is a joke, by the way. Air resistance does exist, but for simplicity, it generally gets ignored when learning, physics in the earlier stages, I guess, if you're getting into physics. But anyway, I don't want to kind of sit here and kind of recollect on every single personal project I ever worked on. But some quick ones that I wanted to touch on is if you're familiar with the iOS Snapchat database app that I wrote, before that was even a thing, before I even thought it into existence, it was originally a Java desktop application, which actually had a GUI, by the way. And I think the inspiration for this is probably fairly understandable, but me and my friends would constantly run into this issue where we would forget what our conversation was with one another. Because if, for instance, like we didn't open someone's Snap for like an hour or two, and we came back and they gave a response without a ton of context, we'd have no idea what the conversation was about. So the goal of this app was literally just to remedy that. Now, this, of course, was back in the day before you could actually save chats. So I guess gives you some context of how long ago that was. But anyway, I wrote this program to essentially allow you to add all your friends and what your conversation was about with them so you wouldn't forget. And as we touched on another project, as we kind of alluded to a little bit in the cybersecurity tip, was I actually wrote my own password manager at one point. Now, granted, this was not the best. It didn't auto-generate passwords. The encryption for passwords was honestly pretty suspect because if I remember correctly, I used a custom encryption algorithm, which not to be confused with my elite encryption algorithm that I've talked about before, but this precursor, if you will, was essentially a glorified Caesar cipher on steroids. So, unlike a Caesar cipher where you essentially pick an offset, say 5, and you shift every letter 5 to the right or the left, whether you're encrypting or decrypting, this would essentially loop. I want to say it was like every 5 or 6 characters, depending on if the string length was odd or even. And essentially, based on where the letter was in that loop, it would increment or decrement by a different amount. So, for instance, this is just an example. I honestly don't remember what the offsets are off the top of my head, but A could be either the letter G, J, D, M, T, or E, depending on what order it happened to fall in, in the context of the string it was in. So a lot more complex than your standard Caesar cipher. But if you knew those offsets and how many iterations in the loop it was pretty trivial to crack the encryption. But nonetheless, I wrote that project because I wanted to. And the last one I want to touch on, which actually I should mention, all of these were Java applications. This was back when I thought Java was the best language ever. But the last one I want to touch on is what I called a basic OS. Now, the reason why I called it that was my goal was essentially to emulate an operating system while running an operating system. At this point in my software development journey, this was by far the biggest project I had ever worked on. I think the final number of lines where it's currently at today, I want to say is around 6,000 and change, but that's a little bit deceptive because, as we'll get into, I kind of incorporated other projects as well. But regardless, it was by far the biggest project I had worked on up to that point. And essentially, it was a fairly basic project in the sense that it gave you the ability to log into an account. There were different levels of accounts. There were admin accounts and user accounts. Admin accounts could do things like create and delete existing user accounts where general users wouldn't be able to do that. Both would be able to update some personalization settings. From what I remember, I think there was really only 2. You had like the background color that you wanted, and you could also set your default search engine because, yes, you could actually search the web. Now, at one point, I believe I even wrote a very, very primitive web browser, but it really didn't work that well, probably because I was pretty much just doing a URL request and then trying to display it, which with the modern web doesn't exactly work very well, so I kind of ditched that not too long after I started working on it, and instead opted to essentially just launch the user's default browser that they had for their actual operating system, and then just launch whatever web browser they had selected as their default. Or when it would launch the web browser, it would then use it would essentially launch to whatever their selected default search engine was, and that was the internet browsing feature. But probably the most significant feature, and the feature I was most proud of with this basic OS, was I developed an entire email system for it. Now, you couldn't send or receive emails from a real email address. So if you had, say, a Gmail account, you couldn't email your Gmail account from this basic OS, and you couldn't have your Gmail account email your basic OS account. But it was all local to this program, but any user account that was on the system, you'd be able to send emails to one another. And that was probably, without a doubt, like I said, the biggest and my most proud feature of the entire project. And it didn't have any kind of support for things like adding attachments, but you could do things, but otherwise it pretty much had everything that you would would find in a basic email client. You could mark emails as unread, you could forward emails, you could reply all, you could send, you had your to, your from, and your CC lines, so you could pretty much everything that you would, like I said, typically find in an email client. It had it, aside from being able to work with attachments, like I said. But in addition to that, there was kind of a hodgepodge of other various projects I threw in there, mainly just kind of other miscellaneous programs I had written, like a Pong game, a snake game, a calculator, and a very, very primitive text editor, which you could only edit files that existed within the basic OS OS itself. So not the most useful, but I mean, it was there. But all of these projects that I've listed to at this point were projects that I was not forced to do. I wrote them because I wanted to. And I wanted to do them because I just kind of came up with the idea and thought it would be cool to do. And through that process, I learned a ton about, software development, how to write code. Because, mind you, a lot of these projects happened like very early on into my software development journey. So I was by no means an expert at anything. So there was a lot of, searching around online how to do things, like the basic OS, for instance, opening up a URL in a default web browser. I had no idea how to do that, but I knew what I wanted to do, and through the process of doing research online, I figured out how you do that, in this case with Java, and that's, basically how I learned. I learned by coming up with ideas for projects that I wanted to do and implementing them. Now, as far as giving you examples about where you should start, that's going to be rather hard to do because I don't know what you're into, so I don't, know specifics. It's hard for me to give specifics since I don't know specifically the things that you're into. But just as kind of a couple quick examples, if you're, say, a runner or a biker or something, and you want to know, what your average speed was on, a run or a bike ride, you could write a program that allows you to enter in the distance you traveled and the overall time, and then it can calculate your average speed. You could make it as fancy as you want. You could throw a GUI on there with like drop downs to convert between different units. Or you could just make it a basic command line program that you just, enter in the speed and the distance, or the time and the distance as command line arguments, and it'll just spit out a result. So you could pretty much, the sky's the limit as far as complexity goes. Another one is a kind of a unit converter of sorts. So if you do like a lot of baking or something and you're constantly having to convert various measurements between different units, you could write a program to allow you to convert those different units for you. And again, you could make it as basic or as complex as you wanted to, with whether that's a GUI with drop downs and selection menus and everything like that, or just a very basic terminal program. Pretty much, like I said, sky's the limit. So kind of the TLDR, or I guess the TLDL, because this is a podcast, of the software development section is, of course, you kind of need to know the basics, but in actual, like, how do I learn to become a better software developer and software engineer, my recommendation is to find a project you're interested in and implement that. So it doesn't have to necessarily be something original. You could, find a program that already exists and try to create your own version of it. A great example is a calculator. There's tons of calculators that exist. Your operating system probably has one included with it, but creating your own calculator is a fairly simple project in terms of there's plenty of examples of how it works, and you can easily test it to make sure it's doing what it's supposed to. And it's a great way to get some experience, going through that software development process. And also, if you want to create a simple game like Pong, for instance, things like that, trying to find project ideas and topics you're interested in and passionate about, and then going through and writing a program to do that thing can definitely help you become a better software developer. So that would be my recommendation for software development. Find something you're passionate about or something that intrigues you and go write a program that does that. And the other thing I wanted to touch on is home labbing. Now, of course, as I've touched on numerous times when talking about how to get started with home labbing, my recommendation here is always not to buy dedicated hardware, at least initially, because I would always recommend that you play around with devices you either already have on hand, or if you only have your laptop or desktop or computer, that you only have one computer, my recommendation at that point would be to spin up virtual machines to essentially kind of give you a small little taste of what home labbing can be like before you then decide if this is something you want to sink your money into, because you will sink your money into it if you get into this hobby. But in regards to home labbing, there's really a lot of different ways that you can get started, because at the end of the day, there is no one thing that is home labbing, right? Home labbing is basically anything you want it to be. The point of home labbing is to have some kind of environment where you can learn, right? Whether that's learning networking for a CCNA, whether that's setting up a cyber test range to play around with various cybersecurity tools, whether that's hosting your own media server, or you want your own cloud storage solution like Google Drive, Dropbox, or OneDrive. You want to learn new technologies like virtualization, Docker, Kubernetes, CI/CD. You want to learn system administration. You do what you want to learn, right? So the key is with home labbing, whatever you want to do and whatever you want to learn and whatever you want to host is what a home lab is. Now, for me, I've done a decent number of these that I've kind of already touched on, improved my skills with virtualization. Before I started my home lab, I had never used Docker before, so being able to play around with Docker, create my own containers, write my own Docker files and Docker Compose files to create things, great learning experience. Again, similar to that, never used any kind of continuous integration before. I think the only caveat to that is my personal websites I hosted on the public GitLab, and I found a GitLab YAML file that can allow me to host my website there, which technically is CI/CD, but I wouldn't consider myself having used it because that was literally a copy and paste job, and I had really no idea how it actually worked. I just was like, oh, this works, cool, and then never touched it. But since then, actually set up legitimate CI/CD pipelines to do things like compile code, run test cases, build Docker containers, deploy that to production, things like that, all because I had a home lab set up that allowed me to do those kinds of things. And then if and or when you decide to buy dedicated hardware, one piece of advice I can give you is don't buy hardware because someone told you to, whether they said it was the best or because they use it. You definitely need to do your own research into the platform or the build specifications of their solution to make sure it's something that you actually want and don't just go in blind. Because just because I say rack-mounted enterprise gear is fantastic and I enjoy using it, that doesn't mean it's for everyone, right? Because for some, the dedicated rack excess noise and heat, not to mention the higher power consumption, could be major deal breakers for people. In contrast, some people that recommend, the latest and greatest mini PC might not cut it for someone that wants to, host tons and tons of VMs and, practice, Kubernetes and, all the various super scalable solutions and Maybe they're trying to be someone that's hosting things for friends and family or something. You have to orient your hardware around what you want to do. If you don't plan to run tons of virtual machines, you don't necessarily need a device that has tons and tons of RAM and compute resources. And also, if you're running a NAS or a network attached storage device, you don't necessarily need a super power hungry rack mount server if all it's doing is backing up files for you. So when it comes to where to start with purchasing dedicated hardware, you really have to kind of identify what your use case is and kind of design and identify your solution around that use case. Because like I said, you don't necessarily need to go overboard on hardware if you're not actually going to use it. Now, that's not saying you can't, because while I probably don't necessarily need all of the resources that my rack mount servers provide me, at the same time, I've very much enjoyed having them and being able to use them. And this last one I kind of want to touch on is kind of, I guess, similar to the home labbing vein, but specifically it is Ansible. Now, this honestly, like I said, could be a part of home labbing, but you can do a lot with Ansible. But the real thing, in my opinion, on the best way to learn Ansible is to prioritize what I consider the quote-unquote Ansible way. And the reason I say that is it's very, very easy to write Ansible playbooks that are essentially glorified bash scripts. And what do I mean by that? Well, in Ansible has the ability to execute shell commands directly through one of its built-in modules. And it's very easy to essentially, if you know what shell commands you want to run, just to repeatedly, have the Ansible shell command and then just put in whatever shell command you need to run and then just have that as your playbook. And the reason why I know that this is easy to do is because I was a victim of this, and this is kind of how I used Ansible early on. Pretty much, there was a couple things I would use the built-in modules for, but largely it was, okay, I know the shell command to do that, so I'm just going to run the shell command. Now, if I'm being honest, if you want to just run a collection of shell commands, I would say just save yourself the trouble and write a bash script and then copy it to your remote hosts and then just execute the bash script, because that's also something that I've done. I've done it also with Python scripts too. You can do it with Python, Bash, whatever scripting language you want, rather than, doing everything through Ansible. But if that's something you want, that's fine. But if you want to use Ansible, I would recommend doing it the Ansible way and using the built-in modules in order to execute things rather than just essentially running a bunch of shell commands, if you will. But again, where do you actually start? Because I said you should, prioritize doing things the Ansible way, but again, where do you start? And I would ask you, what is something you do frequently, whether that's something on your local machine or remote servers? And whatever that thing is, automate that. Now, it doesn't even have to be something you do frequently. It could be potentially a time-consuming process that you might not do all that frequently, but involves a lot of steps. You can use Ansible to essentially solve that for you. So one good use case is if you rarely have to set up or configure servers, but the times you do, you have to do a bunch of various different steps, you can write an Ansible playbook to essentially do all that for you. And this does a couple of things. One, it automates it, which is fantastic, saving you a bunch of time. And because it automates it, it does it a lot faster since you're not having to manually enter all these commands. And two, you get consistent results every time because you essentially remove all human error from the equation of you maybe mistyping something, or you happen to forget what the command was, and then you go find one source that isn't actually the thing you were looking for, so you did it wrong, so then you have to go back and find the actual source, and removes human error from the equation so you can get consistent results. But as far as for me, This task was automating updates. Now, if I'm being honest, when I first started home labbing, it was very fun to manually log into my various servers to run the updates. But as my home lab started to grow, that got old pretty quickly. And to be honest, it got very unmanageable very quickly. Because if you only have to, say, log in to maybe 2 or 3 servers to run updates, it's not that big of a deal. But once you kind of scale that up to like 15, 20, 25 or more, having to manually log in to all those servers to run updates gets very, very old, not to mention wastes a lot of your time. So I essentially turned to Ansible to essentially handle all those updates for me. Now, originally, I only had my Ansible playbook set up to update Ubuntu servers, which, to be honest, wasn't necessarily a huge issue because at the time when I first started out, Ubuntu/Debian-based servers was really all I had. But then, as I started to branch out and use other operating systems in my home lab like Red Hat Enterprise Linux and Arch Linux and things like that, the playbook kind of fell apart. And it didn't fall apart in the sense that it didn't work anymore, because it still did, but it wouldn't update the non-Debian-based servers. So I had to figure out how to solve that, and again, this helped me learn Ansible because I had to figure out how to solve that, and I figured out that you can do conditionals in Ansible to essentially check, what the operating system family is to run certain commands based on that. So, adding, more to my Ansible knowledge because of things I wanted to do with it. But the other thing that I think is a great solution that you can implement Ansible for is whenever you run into what I kind of consider friction blockers or repetitive tasks. And for me, I guess one really good example for it is back, I think I even talked about this on the podcast, is when I wrote an Ansible playbook to essentially toggle my R620's fan control between its normal mode versus the mode to essentially cool the Tesla GPU I have in it in order to run AI models. Because one of the kind of major hangups I had was I had, some AI models, in my home lab that I was playing with. I had Stable Diffusion and I had Ollama installed. But I was very reluctant to actually use them because of the friction to have to go through the manual process of disabling the fan control on the R620 and then logging into the GPU VM where I had the Tesla card and enabling that fan control and then doing what I wanted to do and then going through the reverse of disabling everything. Yeah, it wasn't necessarily that hard to do, but that friction of having to go through and log into the servers and do that was a kind of a preventative thing to making me, or to having me want to use those, AI things. So to kind of remove that friction, I just wrote an Ansible playbook to automate all that for me. And I can just, if I want to play with stuff on the AI models on the GPU, I can just run the playbook to start the GPU fan control. And then when I'm done, I can just stop the GPU fan control and it reverts back to what it was previously. So one thing I want you also to keep in mind is I never had to learn Ansible. My job doesn't require it. I never took a class on it. The reason why I learned Ansible was because I wanted to. And I learned how to use Ansible through identifying things that I wanted to automate in my home lab. Kind of some things we've already touched on. Installing updates on my various virtual machines. Configuring new virtual machines. Like one thing that was kind of annoying was whenever I wanted to spin up a new VM, I had these templates created, but I had to go manually into, I guess I didn't technically have to go into the GUI, but I did go into the GUI, shut down the VM, clone it, boot the VM up, configure it how I wanted it to, and then boot the template back up so there wasn't any kind of conflict. And that was a very manual and kind of gross process. So instead, I just wrote a couple Ansible playbooks to do all that for me. So now I have Ansible playbooks that I can essentially clone VMs from the various templates I have created that I can just select which one I want to clone and it'll do that for me. And then I have a script set up, or another playbook available that I can, based on whether it's a Red Hat based or a Ubuntu or Debian based or an Arch Linux based virtual machine, configure it properly to essentially be a complete clean slate that I can then go and do whatever I want to do with it. So whereas before that was a very manual process, because and mind you, I didn't necessarily know how to do any of this stuff in Ansible before I, went about doing it. But by going through the process, it helped me learn Ansible better by doing these things. And probably one of the more notable things I've done with Ansible was installing services. Like, for instance, the guacamole through a Docker playbook, that I created, that also happens to be on my GitHub, which will essentially run an Ansible playbook to configure a virtual machine or server in general to run guacamole in a Docker container through Docker Compose. And mind you, a lot of that stuff I didn't necessarily, it was a learning experience, going through, because I didn't know how to do everything with Ansible. But, I kind of knew enough to, know what I needed to look for, and it helped me to become better with Ansible and help learn how to do things the Ansible way. And then probably one of the more famous ones, if you've listened to the podcast for a while, is my backup script, which is essentially a collection of Ansible playbooks to automate the backup process for my NAS. So, like I said, I didn't know how to use Ansible before I started my home lab. And through the process of using Ansible and learning how to use it through these things that I wanted to automate, helped me become a lot more knowledgeable with Ansible. And I've honestly have to say I've learned quite a bit. Now, I'm not going to sit here and say I'm an Ansible expert, probably far from it. But I'm at the point now where I know enough to kind of know what I want Ansible to do and the capabilities of it. And if I don't know how to do something, or off the top of my head, I have a collection or a library of reference material to refer back to. And even if that doesn't include it, I know the basic modules, then things that I can look up to quickly get these solutions that I'm after. So I think out of all of these, Ansible was probably the most relatable solution or relatable scenario that I can give to someone that wants to start something from scratch without going through a formal education process. Because, like I said, I kind of came across Ansible because it was something that can help me automate things. I had no previous experience on knowing how to use it. But because, over the process of identifying things I wanted to automate, and through that, I was able to learn the various, modules and components and capabilities that Ansible has in order to fulfill those requirements that I set out for myself in order to learn the technology. So hopefully that can help you, kind of give you some ideas for where to get started with things. But kind of the summary of this is kind of like I said at the very beginning. Always, if you're trying to or want to learn something new, learn so by doing what excites or intrigues you about it. So in the case of Ansible, for instance, I wanted to automate how I do updates, or I want to automate how I set up virtual machines. And through that, it can help me use Ansible to then learn how to use it and become better at it. Same thing with software development. Find a project or a thing that you want to implement and use that as your learning opportunity. So whenever you're trying to figure out where to start, try to identify what excites you or intrigues you about that thing and then start from there. So I think that's probably going to about do it for this episode, but of course we have to get back to our trivia question for the week, which is the first x86 processor was the Intel 8086, which was a 16-bit processor that was an extension of Intel's 8-bit 8080 microprocessor. But what year was the Intel 8086 released? And spoiler alert, it was not released in 1986, in case you were wondering. If you said 1978, you are correct. So congratulations if you got this week's trivia question correct. And if you enjoyed this episode, definitely be sure to leave it a rating and review and subscribe if you haven't done so already. And be sure to share this episode around, especially if you have or know anyone that's kind of struggling with this idea of where to start, or if they happen to be one of those people that use password or 123456 as their password. Maybe you can kind of send this to them as a maybe passive-aggressive way of telling them to update their passwords. But regardless, definitely be sure to share it around with friends and family. And if you have any questions or ideas or comments or topics or anything of that nature about this episode or future episodes, shoot me an email or leave a comment down below if you're on YouTube. But you can email contact@darkassassinsinc.com. And if you have any topics, ideas, or anything like that, I will definitely be sure to include them in future episodes of the show. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bull nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.